All right, let's talk about what Google just pulled off with Titans, because this is genuinely wild. For the longest time, AI models have had this fundamental problem. They can't remember things properly, not in the way you or I remember. And Google might have just cracked it, but there's a catch, and we need to talk about that too. So here's the thing. Right now, when you're using ChatGPT or Claude or any of these models, they're not actually learning from your conversation in real time. They're just holding everything in temporary memory, like RAM in a computer. Once that context window fills up, they start forgetting stuff. It's like trying to have a deep conversation with someone who can only remember the last 10 minutes of what you said. Frustrating, right? Transformers, the architecture that powers basically every major AI model today. They're incredible at short bursts. They're precise, they're detailed, they understand nuance. But push them too far. Ask them to handle massive documents, or remember context from hours ago, and they crumble. The compute cost skyrockets, performance tanks, and suddenly your super intelligent AI can't remember what you told it 3 pages back. Google tried a different approach with Titans. Instead of just accepting these limitations, they built something that actually learns while it's running. And I mean genuinely learns, not just pretends to remember by searching through a long text file. Titans uses what they call a long-term memory module. It's separate from the main attention mechanism, and it updates dynamically as the model processes information. Here's where it gets interesting. Titans doesn't just save everything blindly. It's selective. It decides what's worth remembering based on surprise. If something unexpected shows up, something that doesn't fit the pattern, Titans flags it and stores it. And when it forgets, it doesn't just wipe old data randomly like most systems do. It forgets strategically, keeping what matters and letting go of redundant information. Google actually built 3 different versions of this memory system. Memory as context, memory as gate, and memory as layer. The one that performed best, memory as context, is the one that's making everyone's jaw drop. We're talking about context windows over 2 million tokens. That's not a typo, 2 million. For reference, GPT-4 Turbo handles around 128,000 tokens. This is on a completely different scale, and it's not just about capacity, it's about performance. Titans with only 760 million parameters, which is tiny by today's standards, outperformed models with tens of billions of parameters on long context tasks. On the needle in a haystack test, where models have to find specific information buried in massive documents, Titans hit over 95% accuracy at 16,000 tokens. Most models fall apart way before that. Then there's the Babylon benchmark. This is brutal. It tests whether a model can connect facts scattered across enormous texts, things that require actual reasoning across long distances. Titans didn't just beat other models, it destroyed them. We're talking about beating GPT-4, beating Llama 3 with 70 billion parameters, even beating Llama 3 when it was paired with retrieval tools designed specifically for this kind of task. But here's the part that's even more interesting. Google didn't stop at Titans. They introduced something called Miras. And this is where things get philosophical. Miras is basically a framework for understanding all sequence models as variations of the same core idea. Transformers, Mamba, RetNet, RWKV, all of them are just different ways of storing and retrieving information from memory. Google broke it down into 4 fundamental questions. What shape is the memory? How does the model decide what to store? How fast does new information replace old information? And how does memory get updated over time? With Miras, they created new models, Moneda, Yad, Mamora, each exploring different answers to these questions. And some of them actually outperform both Mamba 2 and traditional transformers on ultra-long context tasks. This is huge because it signals a shift. We're moving away from the idea that you just pre-train a model once, freeze it, and deploy it. Instead, we're heading toward models that learn continuously, that adapt in real time, that build knowledge as they interact with the world. And you can see this philosophy showing up everywhere. Ilya Sutskever, one of the most influential people in AI, recently said he wants models that learn the way a talented teenager learns, actively, continuously, not by grinding through mountains of frozen training data. So what does this actually mean for you? Well, if Titans and Miras work as well in real-world applications as they do in benchmarks, we're looking at AI that can actually maintain long-running conversations without losing track. AI that can work through entire code bases, legal documents, research papers, without forgetting critical details halfway through. AI that doesn't need to be retrained from scratch every time it encounters something new. But, and this is the big but, there's a question we can't ignore yet. Lab results don't always translate perfectly to real-world performance. Titans looks incredible on paper, but how does it handle noisy data? How does it perform when users throw unpredictable, messy, real-world tasks at it? How does it scale in production environments where cost and speed matter just as much as accuracy? Google's been quiet about deployment timelines. They've published the research, they've shown the benchmarks, but we haven't seen Titans rolled out in Gemini or Bard or any consumer-facing product yet, and that's worth paying attention to. Because if this technology was ready to ship today, they'd be shipping it. There's also the question of how this fits into the broader AI race. OpenAI is reportedly working on something called Garlic, a new model aimed specifically at outperforming Gemini in reasoning and coding. Anthropic just dropped Sonnet 4.5, which is pushing boundaries in its own way. And now you've got models like Lux from OpenAGI Foundation that are rewriting what AI agents can actually do with computer interfaces. So Titans might be the breakthrough everyone's been waiting for. Or it might be one piece of a much larger puzzle that's still being assembled. Either way, the fact that Google is openly exploring memory systems that learn in real time, that adapt dynamically, that break free from the limitations of static transformers, that alone tells you where this is all headed. The era of frozen, one-shot pre-trained models is ending. What comes next is going to be way more interesting. Thanks for watching, and I'll catch you in the next one.